Yes.
Makes it more interesting.
Yes. The new language. Do we have the third presenter here? Ready? Okay. Okay, good afternoon, everyone. Hope you have enjoyed your lunch here. So now we have this session, parallel session. We have 6 presenters lined up. So in the way we do it is we will have 3 presenters present their during their presentation. Each one will have 8 minutes, and we have 2 minutes buffer to switch the presentation for each one. Then we will have a QA for every 3 presenters together. So now with that, I would like to introduce our first presenter, Professor Mani Golparvar-Fard from UIUC. Thank you.
Thanks. Good afternoon, everyone. Pleasure being here. My name is Mani Golparvar, as I was introduced. My students and I, we had 2 papers at this event, and now I've been told that I have to do both presentations in 8 minutes. Obviously, I will not be able to cover all of it. So instead, what I'm going to do is I'm going to make a few slides to communicate most of the idea. So my co-authors are Juan Nunez-Morales, who graduated in my lab and is working at FACO, and Yoonhwa, who's interning at DocuCrunch technology company. The paper that we have is on the idea of mapping what we do with image segmentation, a computer vision technique that we use on job site imagery, and how we want to use that at the base of updating schedules without using BIM. So that's the baseline for that work. The second paper is also the same sort of high-level issue. Go back. This one touches on a new technique. It's a vision language data set for deep learning-based techniques that offers a new data set that we're releasing for the first time at this event. So last few years have been really exciting years for our community. Let me see if I can advance the slide here. We haven't here any issue up. All right. The very first time I had the opportunity to speak about construction monitoring almost goes back 17 years ago, when this was a research topic. Since then, we've come a long way. The number of job sites that have been exposed to the practice of taking photos and videos have dramatically grown. In fact, in 2024, based on almost a dozen of software solutions that have been used in the market, our assessment is that a little bit over 100 billion square feet of space has already been captured. When I was speaking about the capture, is the ability of using drones, which fly over job sites to take photos, using 360 cameras. How many of you in the room have seen 360 cameras? Extremely popular with superintendents. They mount them over their hard hat, they walk around. And of course, an alternative solution that we have, a camera that can be mounted on a tower crane that mimics what a drone does. The gist of it is the following. People walk around the job site, take a lot of photographs. These photos are being processed, typically using image-based 3D reconstruction techniques. At the professional level, we usually call them photogrammetry techniques. And the deliverables are 2-dimensional orthophotos and 3-dimensional point clouds. So this has become a common practice. There's almost no single job site that my company's on that we don't use it. And we've been on almost 4,000 job sites so far. So this technology has been used on that many job sites. The gist of it is the following. As photos and videos are being captured, models of reality are being generated. Then you upload your design, you upload your schedule. You can integrate the two. So at any moment in time, you have a snapshot of what is expected to be built on the job site and the reality. And of course, the two can be twinned together in the same coordinate system. Once the twin is achieved through a number of interactive techniques, a number of semi-automated techniques, usually you end up getting your work packages, location, or areas color-coded. So you see the schedule at the bottom of the screen. There's an orange timeline, a slider that shows you what snapshot in time you're looking at the site. You see what the design and schedule are dictating to you. And of course, the reality shows you how much work has been done. This capability has been enhanced to indoors. So if you have not seen these experiences before, this is what it looks like. You basically walk around with the 360 camera. It's a structure for motion-based algorithm that is being used with an architecture that's efficient enough that is running on the cloud. So video is uploaded automatically, and it generates these two types of deliverables. So you get a floor plan automatically generated from the point cloud, and the donuts you see on the screen are frames that are extracted from the video. When you generate the reality model like the one you see on the screen, the scene is entirely measurable because there's a point cloud in the back of the scene, and it supports the capability. So these capabilities have already made it to the market. Like I said, thousands of job sites have already been exposed to it. And owners and clients that we work with, they're asking for more. The demand for automation has increased over the past few years. Now, in the old days, we used to see this in oil and gas community where people used to ask for earned value analysis. But now, interesting enough, in the United States, we see that with healthcare community, Pfizer, Kaiser Permanente, for example, data centers. We've had the opportunity of working with Meta, the company that owns Facebook, Microsoft, Apple. They've all mandated generating earned value reports, and also electric vehicle and chip manufacturing plants. The main drivers for automation are two things: payment application. On average, every contractor in the United States is behind their payment by 2 months. So the ability of being able to verify the work complete and issuing that payment is one of the drivers for these types of reports. At the same time, for many of these projects that we engaged, the nature of the contract is requiring the owner to make sure the project ends up on schedule. So risk mitigation for any T&M job, which is time and material, or GMP guaranteed maximum price, are driving these reports. But the nature of the request for reports have transformed over the past few years. One, broadly speaking, owners are interested in comparing design against the reality of the work without a schedule as one deliverable by itself. Two, ability of updating the schedule without 4D BIM. So there's no 4D BIM, complete separation of a schedule model. And lastly, when it comes to punch lists, the idea of being able to count how many elements that we have and where are these elements located. Now, over the past 5 years, venture capital firms have put a lot of money into these solutions. That is a market for it. These solutions that are dominantly service are driven by having human in loop. What I mean by human in loop is that people actually sit down and manually generate reports that are sold, obviously, to the owner. So in this case, you see an example of a company from Europe that actually has a model that is overlaid, color-coded. And on the right side, you see a two-dimensional quantity takeoff of a drawing that is also color-coded. These are the common challenges that we see. Oftentimes, when you work with owners and clients, they're asking, what is the accuracy? Their definition of accuracy is not the same as the accuracy that we discussed. And often I've heard from vendors that they claim their systems are 96% accurate. What else do I hear? How many Uniformat classes? There are vendors that many owners interact with, and I've sat in these sales presentations. Many of them are claiming that they can capture 85 work packages, 135, and I'm not naming the companies, but these are real values that you hear from them. Then you ask them, what is the maturity level for your design models that you would use to compare against reality? And I've heard any LOD. LOD stands for level of development, which doesn't really work that way. So how does it work? They send these models to an engineering team that is offsite. They actually sit down and manually upgrade the model to LOD 400 for those packages that needs to be detected. And people sit down and manually color code components. How fast? These reports are usually generated 1 week late from the time that the capture gets done. And can we do quality assurance and quality control? I know Fred is smiling here, but these guys actually do claim that they can generate automated deviation assessment reports. We've been in this space for quite some time, and many of you have been exposed to this problem. Actually, at this conference, there are 15 papers on the same topic of computer vision. So I thought instead of getting to the technical detail, maybe I'll touch on problems. 3 problems. Detecting and characterizing problem progress from pictures is a still a scientific problem. And I'm going to speak to why this problem has not been solved at scale. The second big problem for us is how do you create a reliable baseline that you can compare against? When you don't have the right maturity in the BIM model, what are the techniques that we can use for that? And lastly, how do you guarantee you have accurate and complete capture in the first place that they can use to compare against the design? So the idea behind the work is the following. When you perform a video capture, we can automatically generate a floor plan. There's a commercial solution that does that. The commercial solution using computer vision techniques would auto-align that reality against the design, like the picture you see here. So we know exact time and location that the capture has been performed. And what we want to do is we want to see if we can use this basis to track progress, perhaps automatically, and eventually update both, meaning be able to reflect on the progress as documented and also the schedule. The way we want to be looking at this is, in this specific paper that we have for this event, is by mapping to Uniformat. We are only looking to commercial buildings where ASTM Uniformat applies to, and want to see how we can push the idea of image segmentation and automatically label different elements based on Uniformat. Now, this becomes an interesting problem. If you look into our designs and look into what we detect from reality, these are two completely separate issues. Uniformat classes, if you look into a BIM model, you may simply model a drywall and non-visual information would be enough for you to declare it as LOD 400. But if you want to do visual progress monitoring, you need to know framing, insulation, gypsum board, plastering, painting, and whatnot. So in this work, there are a few elements of that you can tap into. One, we've actually formalized mapping between what we call visual states of progress against 650 Uniformat class of objects. This has been validated. So you have these states. What that does is that when it comes to image segmentation, you actually don't have to worry about Uniformat. All you need to do is to make sure you look into these states of work in progress. Once that detection is done, we use the Uniformat as a guide to map what we detect from images, use Uniformat as a mapping against the schedule activities. That's a natural language processing technique that we've done there that brings the Uniformat into a common language. And for now, just imagine that quantity takeoff has been done, whether that's manual or automatic. So we use Uniformat as a common language. So the result of that process, if you can automate it, you would get color-coded 2D designs that are reflective of the progress. And on the right side, you see the progress schedule. I'm not going to get into the details. Like I said, in the paper, you can study them. We've used a Swin transformer model, which is a form of deep learning. Swin is a shifted window strategy for partitioning that actually improves the basis of self-attention for those of you who work on deep learning. It has proven to outperform VIT models. At this event, many of computer vision papers are using VIT models. The novelty here is that apart from that state-of-the-art technique that uses appearance, we're tapping to geometry because it's a point cloud, and we're improving the basis of that. The second contribution of this paper has to do with synthetic data. Now, I'd like to leave you with one thought-provoking idea. Deep learning algorithms, at best, they learn abstraction of the reality. There's nothing more that they can learn. So the idea that we are pushing here is to see if we can learn abstraction of the reality through design. That's what we do in our design. So if we can use BIM and create a walkthrough path within the BIM, we can artificially create images that are associated with normal maps, depth maps, and ground truths, and you can use them as a base of the work. Again, I don't intend to get into the details. In the paper, you can actually see the efforts that we've done. There are a number of new techniques that tap into multi-view inference that relate what we can detect from pictures against areas that are manually color-coded in drawing from a quantity takeoff perspective. We have a new paper that was just published in Automation in Construction. It touches on using natural language processing, a totally different transformer model in this case, and it automatically maps the schedule activities against Uniformat. And ultimately, in the paper, you can actually look into a simple workflow that we've offered that is validated, that projects reality mapping in 2D at multiple elevations, be color-coded, and then we compare that against a quantity. The mean absolute percentage of the error that we've observed so far is actually less than 6%, which for first few studies that we're performing is actually pretty remarkable in terms of what it can achieve. Again, I don't intend to get into the details. There's a lot of details that's offered in the paper, but the key idea is the following. Use Uniformat to map computer vision image segmentation to schedule activities that are processed through NLP. And the data requirement for this will be making sure you have reality mapping projected in 2D. What we need to do is to validate this at the scale. So as I said, there's almost 650 Uniformat classes. We haven't validated all of them. Our synthetic data set is almost 11,000 images that at CVPR conference, it will be released to public so anyone can use. And we want to scale that up. And of course, the last problem is the automated quantity takeoff. So I'll stop here. Thank you.